The Hai Van Pass is a geographical masterpiece. Carved into the rugged Annamite range of central Vietnam, it is a place where breathtaking beauty hides unforgiving danger. For ordinary travelers, it is a scenic coastal route. But for the men who pilot heavy commercial vehicles, it is a daily battlefield. A relentless struggle against gravity, friction, and the limits of mechanical endurance. Today, we will analyze the extreme physics and driving psychology required to conquer this mountain. We begin our observation at one of the lower switchbacks. A Chenglong H7 articulated lorry is navigating a severe hairpin turn. Trailing behind it is a flatbed carrying a heavy crane system. Despite the sharp geometry of the curve, the driver maintains a steady, continuous speed. This reveals a relatively light payload for a truck of this class. The kinetic energy carries the vehicle through the apex with minimal steering correction. The dry asphalt and clear weather provide an optimal coefficient of friction. But the true test of the mountain is approaching from below. Moving up the gradient is a formidable machine. A Shacman X3000 heavy-duty tractor unit. Secured to its lowboy trailer is an imposing cargo of industrial drilling equipment and heavy steel pipes. This payload fundamentally alters the vehicle dynamics. The center of mass is elevated. The gross combination weight is immense. The driver is now approaching the most notorious hairpin on the pass. This specific turn combines a nearly 180-degree switchback with a sudden drastic increase in elevation. It is a nightmare scenario for any long wheelbase vehicle. Listen closely as the engine tone deepens. The driver is attempting to carry his momentum into the incline, but the sheer mass of the cargo acts as an anchor. Gravity overpowers the forward momentum. The truck stalls mid-turn. This is the most critical moment in heavy haulage. Losing momentum on a steep incline means the vehicle must now overcome static inertia from a dead stop. The sharp hissing sounds you hear are the pneumatic air brakes releasing. Heavy trucks rely on pressurized air to disengage the brake pads. The driver is forced to let the massive rig roll backward. He must sacrifice his hard-earned ground to create space for a second attempt. He needs a wider angle of attack to prevent the trailer wheels from dropping into the inner ditch. This is a geometric phenomenon known as off-tracking. The rear wheels of a trailer always follow a shorter path than the front wheels of the cab. On a turn this tight, the driver must steer the cab dangerously close to the outer edge of the cliff. He engages the forward gear again. The engine roars as thousands of combustion cycles fight against the incline. But the physical forces at play are brutal. Notice the front wheels of the tractor unit. They are turned sharply toward the mountain, yet the truck is not turning. It is being pushed straight ahead. In automotive engineering, this is known as severe understeer. When a truck pulls a massive payload up a steep hill, the weight transfer shifts violently to the rear drive axles. The front steering axle becomes incredibly light. It loses its downward pressure on the road surface. Without sufficient weight pressing the tires into the asphalt, the rubber simply scrubs against the ground. The steering wheel becomes useless. The driver is trapped in a physics paradox. If he applies more power, the front wheels will push further out of line. If he stops, he loses all momentum again. He abandons the attempt. This is not a failure of driving skill. This is a masterclass in risk management. Pushing a compromised vehicle on a cliffside road leads to catastrophic accidents. Patience is the only safe option. The driver sits idling, allowing the vehicle air compressor to rebuild pressure. Air brakes are a fail-safe system. If air pressure drops too low from repeated braking, the brakes will lock automatically. He must ensure his pneumatic system is fully charged before making another move. The physical toll of this maneuver is immense. The clutch plates are absorbing massive amounts of heat. The transmission gears are under extreme shearing force. He reverses once more. This time, he positions the cab at a slightly different angle. He is calculating the exact trajectory needed to pull the dead weight through the apex. He engages the transmission, but there is a hidden weapon he must deploy here: the differential lock. Normally, a vehicle differential allows wheels on the same axle to spin at different speeds. This is necessary for cornering, but on steep, uneven gradients with heavy loads, an open differential will send all the engine power to the wheel with the least traction. That wheel will simply spin uselessly. By engaging the differential lock, the driver forces both drive wheels to spin in perfect unison. This guarantees maximum mechanical grip against the road surface. The tires bite into the pavement. The chassis twists under the immense rotational force. Slowly, agonizingly, the machine creeps forward. The cab aligns with the exit of the corner. The driver has defeated the mountain most difficult geometry. He accelerates, pushing the engine to climb out of the danger zone. Let us examine the power plant making this possible. The Shacman X3000 is typically equipped with a large displacement diesel engine, producing up to 460 horsepower. But horsepower is not the crucial metric here. The lifeblood of heavy haulage is torque. This engine generates roughly 2,200 Newton-meters of torque. To put that into perspective, an average family sedan produces about 200 Newton-meters. This truck has 11 times the twisting force of a normal car. It is designed to rip heavy loads out of deep mud and haul them up vertical inclines. But mechanical power alone is completely useless without the human element. The driver must perfectly synchronize his throttle application with the bite point of his clutch. As the truck climbs higher, the nature of the road changes. The wide switchbacks give way to narrow, sweeping curves hugging the cliff face. Blind corners present a terrifying psychological challenge. In these sections, the ascending truck has a massive disadvantage. A heavy vehicle climbing a hill relies on continuous kinetic energy. If a descending car or truck takes the corner too wide, our driver will be forced to apply the brakes. Stopping a fully loaded rig on a steep, narrow incline is dangerous. Starting it again from a dead stop is a mechanical nightmare. You can see the driver carefully hugging the outer lane marker. He is anticipating oncoming traffic. Notice how the front suspension compresses slightly when he shifts gears. The payload is constantly shifting its weight backward and forward. These micro shifts demand constant steering corrections. The driver arms and shoulders are experiencing extreme fatigue. The steering box may have power assist, but fighting the momentum of dozens of tons requires immense physical input. He approaches the final sequence of ascending curves. The elevation is nearing its peak. The air is slightly thinner, which fractionally reduces the oxygen density for the engine combustion cycle. The turbocharger works overtime, forcing compressed air into the cylinders to maintain power output. Suddenly, the truck encounters a complication. Traffic is descending from the summit. The driver is forced to bring his massive operation to a halt. He reads the flow of traffic instantly. He understands that forcing his way up will result in a dangerous bottleneck. He yields his right of way. This demonstrates the unwritten code of the mountain. Survival and safety supersede aggressive driving. He holds the vehicle on the incline using the pneumatic parking brake. Once the road clears, he must perform the most difficult hill start of the journey. He builds engine revolutions per minute. He expertly balances the release of the air brakes with the engagement of the clutch. A miscalculation here would send a shockwave through the drivetrain. It could snap a drive shaft or shatter a universal joint, but the truck rolls forward smoothly. The driver has flawlessly managed the transfer of energy. He rounds the final blind corner. The landscape opens up. He has reached the summit of the High Van Pass. But the mission is only half complete. What goes up must come down. And in the world of heavy transport, the descent is vastly more lethal than the climb. Gravity is no longer an anchor holding the truck back. It has become a relentless accelerator pushing the vehicle toward the edge. If a driver relies solely on the pneumatic foot pedal brakes to slow a heavy load on a long descent, disaster is mathematically guaranteed. The friction between the brake pads and the drums generates massive thermal energy. Within minutes, the brake components will superheat. The friction material will glaze and fail to grip. This is known as brake fade. A runaway truck weighing this much is an unstoppable kinetic missile. To survive the descent, the driver must utilize engine braking and exhaust brakes. By keeping the transmission in a low gear, the mechanical resistance of the engine prevents the wheels from turning too fast. The driver essentially uses the engine as an air compressor to absorb the kinetic energy of the falling vehicle. We watch as the Shacman begins its downward trajectory. The speed is highly controlled. The brake lights flicker only occasionally to scrub off excess speed before tight corners. This is the mark of an elite operator. He is saving his physical brakes for emergency situations only. The road widens at a flat clearing near a retaining wall. The driver activates his turn signal and guides the massive machine onto the shoulder. He engages the parking brakes. He steps out of the cabin. The mechanical components are ticking as the metal cools. The tires radiate heat into the mountain air. He has secured a safe parking zone, which is a rare luxury on this narrow pass. We see the crew sitting by the roadside. They are opening simple boxed meals. This brief pause is a stark reminder of the human endurance behind global logistics. These men spend days, sometimes weeks, inside the metal shell of that cabin. They carry the literal weight of industrial progress on their shoulders. They eat quickly, their eyes constantly scanning the truck, listening to the cooling engine, calculating the remaining distance. There is no room for complacency. The descent still holds numerous sharp curves and dangerous drop-offs. Once the break is over, the driver climbs back into the command seat. The air compressor hisses as the brakes are released. The journey resumes. The truck glides smoothly through the lower hairpins. The gradient becomes less severe. The coastal waters come into full view, signaling the end of the mountain range. Conquering the High Van Pass is not a matter of luck. It is a profound demonstration of applied physics. It requires a deep understanding of weight transfer, static friction, and thermal dynamics. But most importantly, it demands human respect for the limits of machinery and the laws of nature. The machine provides the muscle, but the human mind calculates the survival.